In today's extension, we're going to talk about a couple of special functions that are related to linear functions, but they're just a little bit different. So there are special functions. Our learning goal is I will graph piecewise step and absolute value functions. So like I said, piecewise, step, and absolute value functions, those are all related to linear functions, but they each have a little something to them to make them a little bit different. So starting off, we're going to talk about piecewise functions. And a piecewise function is basically combining two functions into one. So let's graph, I'm going to call it f of x, but of course you could also call it y because we're talking about functions. I prefer to use function notation, although in your book they use y, which I think is kind of silly. So this little bracket is going to show that we have more than one piece to this function. We're going to graph -2 if x is less than or equal to 0, and we're going to graph x if x is greater than 0. So here you can see we have our two pieces and we're going to graph it. And really we just need to treat each of those like two separate functions, but they only apply in these certain cases. So let's put down my axis. And the first part of my graph is when x is less than or equal to 0. So if I look at my xy plane right here, we're talking about when x is on this side of the plane. So anytime x is over here, my graph is going to be f of x equals -2, which is just a horizontal line that goes through -2. Let's use a little bit brighter color. So if I were to just graph, sorry, not x, y equals -2, I would have a line, a horizontal line that goes and goes and goes. But this tells me that it only applies when x is less than or equal to 0. So my line needs to stop at x equals 0. And then I need to look back up at my equation, and I see when x is less than or equal to 0, my output is -2. So this needs to be a filled in circle at -2. And then it's going to extend forever in that direction. I'm not going to draw an arrow on this end because this is where my graph stops and I have a new piece. The other piece of my graph is f of x equals x when x is greater than 0. So for this half of my graph, I'm just going to have a line that goes through 0, 0 with a slope of 1. So there's the other piece of my graph. But I need to look back at this 0, 0 point. Remember, when x equals 0, this is the function that applies. So I actually need to have an open circle here. If that were closed, then I would have two different inputs. I'm sorry, I'd have two different outputs for an input of 0, and that wouldn't be a function anymore. So I need to have an open circle for the top piece and have the arrow pointing up, because then as I go in this direction, I'm going to have just a slope of 1. And this is what my piecewise function will look like. So when x is less than 0, the -2 applies. When x is greater than 0, the x applies, or the f of x equals x applies. So this is one possibility for a piecewise function. Just another quick note about these piecewise functions. There can be more than two pieces, and if so, like in your homework, there are a couple that are 3 pieces. You're just going to graph each of the pieces individually. So it can be helpful sometimes if you draw it lightly in pencil and then you erase the half of the graph that doesn't apply. Like if I had drawn this line all the way through, then I would erase this piece down here. That's just one thing that might be helpful while you're graphing these, because it can be hard, especially if you know the intercept, but the intercept doesn't actually apply to that specific piece of the graph. So just keep that in mind, that that's one possibility. Now, for example 2, I'm giving you a graph of a piecewise function, and we need to come up with the equation for it. So what I can do here is I see that I have a function, and I see that it's in 2 pieces. So I'm going to draw my bracket. And I need to look at those 2 pieces and figure out what the equation for each one is. One of the things that can be helpful is to look at that boundary right away. And I see that my graph changes from one to the other when x is -2. So the first graph will be when x is less than or equal to, because that's shaded, -2. And the other piece will be for when x is greater than -2. So those are the 2 pieces that I have. Now I need to look at each of those individually and figure out the equation for that function. So if I look at this one, this top part, I see that I have a slope. I'm going down 2 over 1, and I can assume it's going to do the same thing, as I go backwards. So my slope for the first equation is -2. But I see that my y-intercept is not graphed. So what I can do is I can either use this point, which is -2, 3. I can set up, y equals mx plus b, plug in this point for x and y, and then solve for my intercept. Or I could just continue it in my head and just look. If I went down 2 over 1, down 2 over 1, I would intersect the y-axis right here at -1. So my intercept is -1. So the equation for this piece is going to be f of x equals -2x minus 1, but that only applies when x is less than or equal to -2. Then I look at this piece, and I see I go up 1 over 2, so my slope is 1/2, and here I can see that my intercept is 1. So this equation is really easy to come up with, 1/2 x plus 1. So remember, my first step was to look at where my graph changes from one piece to another, and then I just looked at the equations for those individual pieces and I put them together. This bracket shows that both pieces are going to apply to my situation. For example 3, we're moving on to a specific type of piecewise function that we call a step function. And as we look at the graph of a step function, you'll see where it gets its name from. But here's a pretty basic situation that involves step functions. A store charges $1 to rent a DVD for 1 day and $2 for each additional day. Write and graph a step function that represents the number of days x and the total cost of renting the DVD for up to 5 days. So the first thing we're going to want to do here is to make a table just so we can figure out what our values are. So if x is the number of days, then f of x is how much money we have to pay. If we rent the movie for 0 days, we pay $0. But if we rent the movie for anything more than that, we're going to have to start paying. So if we rent the movie for between 0 and 1 day, we have to pay $1. Now, if we rent it for exactly 0, then we don't have to pay anything because we haven't actually rented a movie. But if we rent it for up to 1 full day, we pay $1. So it's greater than 0, but greater or less than or equal to 1 day. If it's exactly 1 full day, we still pay $1. If it's in between 1 day and 2 days, we're going to pay $3 because we've already paid the $1 for the first day. We're paying $2 more for the next day. And then if we're between 2 and 3 days, we have to pay $2 more, which would be $5 total. Between 3 and 4 days would be $7 total. Between 4 and 5 days, we're going to pay $9 total. So you can see we have a whole bunch of intervals here. If I rent a movie for a day and a half, I'm still going to have to pay $3. They're not going to charge me a fraction of that $2 because I only rented for a fraction of a day. It doesn't work like that. A lot of times car rentals work the same way. If you rent a car and it's $25 a day, it doesn't matter if you rented it for 1 day and 1 hour or 1 day and 23 hours. You pay for 2 full days of renting it. So same situation here. So you can see we have our intervals. Between 0 and 1 full day, it's only going to cost $1. Between 1 full day and 2 full days, we pay $3, etc. So when I graph this, that would be 1, 2, 3, 4, 5 days. So at 0 days, I pay $0. Let's say 2, 4, 6, 8, 10. So this is, if I label my graph, this is my x-axis, which is number of days. My y-axis then, or my f of x, is going to be my total amount paid. So 0 days, I pay $0. But between 0 and 1, I pay $1. So I have an open circle at 0, and my graph is going to be 1 until I hit 1 day, and that's a filled in circle. And then any minute after 1 full day is going to jump me up to costing $3. So I'm going to have an open circle here and a filled in circle here. So anywhere between 1 and 2 days will cost $3. And then I'm going to jump up again, because as soon as I hit 2 full days, or any more than 2 full days, I'm going to have to pay $5 now. And that will go through until 3 days. As soon as I hit 3 days exactly, 1 minute past that, I jump up another $2. And then I jump up another $2. So you see that I have my open circles on the left-hand side, because it's right up until I hit 1 full day, or right up until 2 full days. And as soon as I go past those 2 full days, that's when my cost is going to jump up, and I'm going to get charged for 3 days. And then, as soon as I hit 3 full days, my cost is going to jump up, and I'm going to get charged for 4 full days. So this is a step function, and I think you can see why it's called a step function now, because they kind of look like stair steps that jump up. So this is what a step function is going to look like. A lot of times you're going to see step functions when you're talking about renting things, whether it be equipment, DVDs, karaoke machines is the example in the book, anything like that. So we have constant values over little segments that jump up for every day that goes by.